All right, so again, one of the reasons I am sending that is because, as you can see, it is kind of difficult to read up on that screen, but the idea is, and I know a lot of you are saying you weren't struggling with the chain rule, but really the algebra behind it. And that is one of the trickiest parts about these types of problems is the actual chain rule themselves is fairly simple, but deciding how, what, and where to simplify can be the challenge. So the rule is kind of don't oversimplify. And the second rule is to really watch your parentheses. So here, if you're going to distribute the 5, then you have to make sure you group the 10x and the 20. Over here, in this example, I did not distribute. So what you'll notice is that the 4 stays out in front. You still have to make sure you group together the derivative of the second part. So during the chain rule, one of the biggest problems or errors students tend to make is not including parentheses. So you are better off making sure you put more parentheses and keeping your grouping simplified than you are to accidentally miss a set of parentheses. So then down here in number 3 and in number 4, you can see that these are grouped. I did drop the negative exponent down to a positive. So we have a tendency not to leave negative exponents. That's sort of a no-no. And then here, again, didn't oversimplify, probably could have simplified even more. But what I did was I looked for the big pieces that were like terms and kind of pulled them out. And if you didn't do that and you stopped the line above, that's okay as well. Typically, if we're going to see one of these questions on the AP exam, they're probably going to make it in multiple choice, and they're probably going to stop at that middle line where they know that you can simplify, you can organize the terms from least to greatest, and then move on from there. Just because of spacing, I didn't show the work for number 6. If number 6 is something we think we need the work for, I can gladly go do that off to the side. Hopefully you're able to remember and recall the laws of exponents, which say that if something is raised to the 3rd power outside, then everything is raised to that 3rd power. So it's kind of like taking x minus 6 cubed over x plus 7 cubed and then doing our quotient rule, which is how in the denominator you ended up with x plus 7 to the 4th because you're able to simplify it out from the numerator. Similarly, that's how I did and treated number 5. I used the quotient rule. So what I did was said, okay, the derivative of the top is 0, and then took the derivative of the bottom and all of the terms in between. So our final answer, number 5, was that negative 8 minus 8 all over x squared minus 2x minus 5 to the 5th. Okay, and then 7 and 8 were using square roots. So in 7, I brought the square root up as a negative. By bringing it up as a negative, I felt it simplified my problem a little bit instead of trying to do the quotient rule. Although again, using the quotient rule, you would have just zeroed out. Either way, you should end up with that negative 2 over 5 quantity 2x minus 1 to the 6th fifth. Okay, number 8. We have 2x minus 7 over quantity 2 square root x squared minus 7x. And then 9. 9 was a little bit messy, so you had to do your quotient rule. And 10, once again, 10 was actually the second derivative of number 6. So if you got that answer in number 6, basically you were taking the derivative of that again. So again, I did 6 and 10 on a separate sheet of paper, which I can gladly send to anybody that wants to see it. And hopefully this kind of creates some clarity. I know, again, you were saying it wasn't the chain rule that was hurting you, it was the algebra. And what could you do kind of to simplify that algebra? Okay, and then on the back, okay, on the back, we basically are given a series of functions, and those functions have set values. So instead of being told what the functions are, we're just told what the functions are at certain points. So in orange, which it kind of looks like a muddled brown, what I did was take the derivative and basically leave it for you to see, and then in the pen, what I did was take that derivative at that particular point. So in A and B, you can see that the derivatives are up there, and then here are our solutions. So then looking at E and F, again, these aren't chain rules, they're power or product rules. And again, because 7 and 6 aren't functions, they're really just coefficients. So it just becomes a multiplying of 7 times G prime at 0 plus 6 times F prime at 0, which then simply becomes negative 21 plus 12. And then now you're just, again, doing basic algebra. We're going to add the negative 21 to the 12 to get a negative 9. And then over here, letter F. Letter F is a little trickier. So that's like saying the function squared. So I rewrote it as g of x squared plus f of x cubed. And then you take your derivative. So this is a chain rule where it is a power with a function in the middle. So it's derivative of the outside of the power. Function on the inside stays times derivative of the function. Same over here with f, so it became 3f of x squared times f prime x, which then became 2 times g of 0 times g prime at 0 plus 3 times f of 0 squared times f prime of 0. So then you had negative 15 times 2, which is negative 30. Plus negative 1 squared, which is 1, times 3 times 2, which is 6. So then you get negative 24. And then down here in letters A through D, it's all of the same derivatives from up above. So in A, we're just going to do that same plugging in, but now you're finding the derivative at 2. So this is like f of 2, which is 1, times g prime of 2, which is negative 4, plus g of 2, which is 3, times f prime of 2, which is 2. So then you get negative 4 plus 6, which is 2. Letter B, so again, it's the same as the derivative of letter B up above. So it's g prime 2 plus f prime 2. So it's negative 4 plus 2, which is negative 2. And letters C and D, once again, are the same derivatives as letters C and D above, except for at x equals 2. So this is f of 2, which is 1, times g prime of 2, which is negative 4, minus g of 2, which is 3, times f prime of 2, which is 2, all over f of x squared. So you get 1 squared, and then that's really negative 4 minus 6, or negative 10. And letter D, it's g of 2, which is 3, times f prime of 2, which is 2, minus f of 2, which is 1, times g prime of 2, which is negative 4, all over 3 squared. And then that becomes 6 plus 4 over 9, or 10/9. Okay, letter E. So letter E is different now. Now you have to take the derivative. So again, that's like a constant. So it's 3 g prime of x minus 2 f prime of x. Now the second part is a product rule. So I'm going to treat the negative on the outside. And then it's going to be the first, which is 2g of x, times the second, which is f prime x, plus the second times derivative of the first, which is 2g prime x. Then I'm going to plug in my values. So it's 3g prime of x, which in this case is negative 4, minus 2 times 2, minus, that negative is going to distribute to both terms. So it's 2g of 2, which is 3, f prime 2, which is 2, minus 2, f of 2, which is 1, g prime of 2, which is negative 4. And then now it's just simply cleaning up your math. So you have negative 12 minus 4 minus 12 plus 8. So then negative 24 minus 4 is negative 28. Negative 28 plus 8 is negative 20. Okay, letter F. Letter F is more like letter F from above, where you have that power on the function. So that first one would become 2 times 2 times 4 g cubed x times g prime x minus 4 times 5 f to the 4th power of x times f prime x. So 2 times 4 is 8. G of 2 is 3, but then that's cubed. G prime is negative 4. Minus 4 times 5, which is 20. F of 2 is 1, so 1 to the 4th is 1. And then f prime of 2 is 2. So 3 cubed is 27, and then 27 times 8, and 27 times 8 times negative 4 is a negative 864. Ew, I went back to orange. And 2 times 20 is 40. So you get negative 904. And then G and H are the chain rule by its most basic definition, composition. So it's outside in. So it's G prime f of x times f prime of x, and then derivative of x is 1. If it was something other than an x inside f of x, you would multiply by its derivative. So again, looking at these at 2, that's like saying g prime of f of 2 times f prime of 2. So f of 2 is 1. So this is why the table expands, because now we're looking at g prime of 1 times f prime of 2. So g prime at 1 is negative 7. F prime of 2 is 2. So the answer is negative 14. Letter H, this is f prime g of x times g prime of x, and then f prime of g of 2 times g prime 2, which is like f prime g of 2 is 3, so it's f prime of 3 times g prime of 2, which makes our final answer 0, because the derivative of f at 3 is 0. Okay, so again, hopefully that helps create some clarity on that handout. I know that the algebra is a lot. It's a lot to take in. It's a lot to work with. So hopefully that helps kind of clear up any algebraic errors or mistakes we were kind of feeling for that. The next thing I want to do is go over the beginning of last night's homework. So I'm just going to put up the answers, and then if you have any questions or any problems you want to see more in depth, we can definitely go ahead and go over that. Cosecant squared x. The derivative of x is just 1, so that's not a big deal. And then we have plus 3 derivative of cotangent x, but before you take that cotangent, you have to take the derivative of the outside, which is the squared. So this becomes 2 cotan x, and then now we take the derivative of the cotangent, which I already said is negative cosecant squared, so then what you'll notice is I have a negative times a negative, which is a positive. Here I have a 2, I have a 2. I have a cosecant squared. So what you can do is take out that GCF of 2 cosecant squared x, leaving behind 1. It leaves the negative 1 here, 3 cotan x. Better? Okay. If that's all the questions on 1 through 8, then we're going to pick back up with the 3 examples left from yesterday's notes. And we're going to go over and discuss how to do them because we're getting into a little bit more complicated trig derivatives today. So you're actually going to go backwards a page in your notes and we are going to finish up these examples here. Okay, so in this example, what you'll notice is now the cotangent is the outside function. Its angle is the sine of x squared. So we have to be really, really careful when we look at these types of problems because we have a tendency to ignore that and we try to do it as like cotangent times the sine, but it's not. It's the cotangent of the sine of x squared. So this is really kind of consisting of 3 functions. It's consisting of the function cotan x, the function sine x, and the function x squared. So essentially what we have is a triple function composition because the first part is g of h of x, which is the sine of x squared. And then that's really like saying f of g of h of x, which is the cotangent of the sine of x squared. So we know from our function composition laws that essentially when we do this derivative using the trig, it should become the derivative of f prime of g of h of x times g prime of h of x times h prime of x. So our goal should be to eventually have the derivative of f and g and h, then keeping those inner parts. So if it helps you, you can off to the side kind of take your derivatives of those functions. So we know that the derivative of cotangent is negative cosecant squared. The derivative of sine is cosine. And the derivative of x squared is 2x. So I know that at some point in my answer, I should see that negative cosecant squared, the cosine, and the 2x. So let's go ahead and find that derivative of y. So the derivative of y is dy dx. So we always want to write it as our derivative, or you could write y prime, but you want to make sure that you show that that's the derivative. So it's dy dx equals the derivative of cotangent, because that's my f, so it's f prime, so negative cosecant squared. And then we know that the g of h of x is going to stay. So it's sine x squared times g prime of h. So g prime is cosine, and h is x squared. So it's negative cosecant squared sine x squared times cosine x squared times h prime of x. And then what we like to do is just clean this up algebraically. So we're going to move the 2x and the negative out to the front. And we have negative 2x cosecant squared sine x squared cosine x squared. Okay. Next up, so this is a quotient rule with a chain rule. So really this is the same as saying the sine of x squared over the cosine of x and we're going to use the quotient rule. So we have dy dx equals ho d high. So now for the d high part, we take our chain rule. So it's 2 sine x, derivative of sine, cosine x. So ho d high minus high. And again, you can write it like this, you can write it like that, doesn't matter. D ho. Derivative of cosine is always negative, so we have negative sine x. And then we have all over the denominator squared. So go ahead, take a minute and clean that up algebraically, and we'll check each other's work in about a second here. So distribute, group, GCF, and I want to see what you can come up with. So take about 2 minutes to do that. Okay, so what you're going to do for the remainder of class today is turn in that packet, and you're going to do those next couple pages. So everything is going to be submitted. So you're going to do 9 to 20 for homework today, and then your assignment for Wednesday is to do that circuit derivative on the next page. So all of that will get uploaded by 7:30 on Thursday morning. So if you finish the 9 to 20 in class today, you can use the remainder of classwork time to kind of start on that trig circuit. What I really like about the trig circuit is if you get an answer that's not there, we know it needs to be there. So every one of those answers is going to get used. If you haven't really done a circuit before, what you do is start on number 1. So what I do is find that derivative. So we can even kind of look at number 1 together just to give you an idea. So it says find f prime of x. So its derivative is 5x squared plus 7 to the 4th. And then you multiply by the derivative of the inside following our chain rule. And that gives you 2x. So again, I would multiply those two terms on the end together. So 5 times 2 is 10x. X squared plus 7 to the 4th. No one wants you to FOIL x squared plus 7 to the 4th. Do not FOIL that. Just leave it as it is. And then what you're going to do is you're going to go look for this answer in one of these gray boxes. So you'll kind of like sort through. And yes, I know it was on that front page. I'm just kind of getting to the point. So we notice that this answer here is right there. So 1, I'm really happy because I found my answer. So what that means is that this is problem number 2. And then what you're going to do is solve problem number 2. So I'm going to label it number 2, find its derivative, and then continue that process for each page. The last thing I want to make note, and I put it on the homework assignment when I made it, make sure there are some negative ones on here. I thought they got deleted. They did not. So when I copied off your papers, didn't delete them. You need to go through, and anywhere you see a -1, we haven't done inverse derivatives yet. That's coming in the future. So you need to go through and delete all of those -1 powers. So we're not taking the inverse derivative. The inverse derivative is not the same as dropping that sign to the denominator. It has a totally different meaning. So it's 14, 15, 16, I believe, and then 17, 19, and 20. You need to go in and delete those -1s. Scratch them out, whatever. So I will stay on, and if you run into questions, if you send me a Teams message, I can come back live and work out a problem, give you assistance, etc. for like the next 30 minutes.